Hi everyone, we're back to answer another chemistry question, and this time is from the 2016 Combined Science Chemistry paper 3, question 1. Name the pieces of apparatus most suitable to complete the following laboratory actions. So part 1 states, separate a precipitate from a solution. So right from the get-go, we see the precipitate is solid and the solution is liquid. So what we're doing here is to separate a solid and liquid. So the best way and the most efficient way is filtration. So what is the apparatus used for filtration is the filter funnel and paper. Okay, so this is the most efficient way. So part 2, measure exactly 22.7 cm³ of solution into a beaker. So the key point here is exactly 22.7 cm³. The decimal place is very, very important. So this is something that you have to take note. Okay, so 22.7, the one decimal place is always used when you are using burette. Okay. Yep. So part 3, collect and measure the volume of a water-soluble gas. So right here, they want you to measure the volume of the gas. Okay, so why did they add the water soluble? So they want to rule out one of the other collection methods, which is the upside down beaker. Okay, so to collect and measure the volume of the water soluble gas, it cannot go through the water. So what we have to what we have to use to collect it is a gas syringe instead. Part 4, add exactly 25 cm³ of solution to each of the several beakers. Okay, so how do we measure exactly 25 cm³? So this is the key point, 25 cm³. Okay, exactly 25 cm³. So what, from our experiments, the apparatus that we use to measure exactly 25 cm³ is the pipette. Okay, so this is part A. So part B, we move down and we see this apparatus being set up to separate pure water from seawater. Okay, so there is the beaker A over here. There's a beaker on top with heat. There's sample A. So sample A is in the beaker being heated up. There's a thermometer here, and then there's a flow, and then you see water dripping out in, and then there's sample B. Okay, so part 1, state the general name for this method of separation. Okay, so from this diagram, it's clearly distillation. Simple distillation. Okay, so we also remember that there's fractional distillation and simple distillation, so we want to be a bit more specific here as well. Okay, so part 2, predict the reading on the thermometer during the separation. Okay, so what happens here? So we want to separate pure water from seawater. So here is seawater, right? Seawater. So when water is being evaporated because of the heat, what temperature does it go to? So it's water's boiling point. So it's 100 degrees Celsius. Okay, part 3. State the purpose of the water in the condenser. Okay, so we look at the condenser right here. Water in at the near the exit point and water out at the top. Okay, so we have to be very careful right here because sometimes there are questions that require you to fill in the water in, water out for a condenser as well, and you have to be very clear. Okay, so why do we have the water in and water out in the condenser? Okay, so as the name states itself, the condenser is supposed to help condense the vapor. So the vapor exits because of the heat here, right? And it enters this tube, the condenser, and it condenses because of the cool water into the pure water that you find here. Pure water. Okay? So we have to say that it condenses. It's to cool down the hot water vapor, so it condenses and flows out as a liquid. Okay? So part 4. 2 samples are taken, one at point A and another at point B. Each is placed in a separate glass evaporating dish and heated to dryness. The sample from A left a white solid and the sample from B left no residue. So explain these two observations. So we need to explain two observations. So first of all, we have to explain A. So A is salt water, right? So when water is evaporated, there is residue remaining because what will be left behind is the salt. Okay, salt is left as a residue. Okay, so B is pure water. So when it evaporates, it leaves no residue because it is pure water. And that's how you tackle this question.